Hello, my name is Artur, and today I will presentation an article with the title "Comparison between Mechanical Properties and the Joint Performance of AA 2020-4351 Aluminum Alloy Welded by Friction Steel Welding, Metal Inert Gas, and Tungsten Inert Gas." This here is the authors by the article. So to start my presentation, I will introduce the team. So the aluminum is a very useful metal in the industry because they have a high strength to weight ratio. So it's very useful in different industries like aerospace, aeronautic, automotive. So aluminum is a very useful metal. We have a problem if you use a weld with aluminum because the MIG and TIG produce some defects like porosity and solidification cracks. So to avoid this one here, we can use the friction stir welding because the friction stir welding is a solid state process, uh, different by the milling jig. The milling jig is a fused process. So if you use friction stir welding, we can reduce this better properties in the weld. So to introducing the main objective, the objective of the article is to compare the friction stir welding and the MIG and TIG process. Okay, so here is the material that will be used in these sheets. The justification is if you can produce a better structures, a better automotives, a better aerospace, aeronautic with a high security, we can produce better products. So if we can study everything and develop it, develop new technologies, we can improve our technology and our science. The methodology of materials, the authors select search for the basic data for these sheets here. Here have the ultimate tensile stress and the hardness for the aluminum sheets. This 8 mm stick to hold sheets for this study here. The field material for the MIG and TIG, they used this electrode here. This electrode is very useful because they avoid some cracks on this structure. Okay. This one here we have a table that the authors write in the article. We can see here the some parameters that used in weld by TIG and MIG, the MIG and TIG process, the current, voltage, welding speed, heat input. So if someone else want to duplicate the study, here we have the parameters to program the weld machine. So here we have the picture of the tool and the dimension by the tool that will be used in the future weld. Here we have the MIG welding, TIG welding. The MIG welding uses argon and helium, and the TIG welding using only argon gas to the process. This one here uses the same electrode, the same material electrode, so we can see here. And efficiency welding uses these parameters here to produce this study. So the methodology of analysis, the authors, the first one is visualizing the mark analysis the weld. So looking for example, some cracks or tunnels on the welding. The next one here is microscopy that to observe the grain structure, like the grain size and other properties in the welded metal, in the steel zone and heat effect zone, for example. The authors searching to the tensile and the hardness in the samples to obtain some mechanical properties. Here we have the results by the author. Now we can see the application by the friction stir welding. So how we can see, we don't have any cracks, any tunnels. So the friction stir welding is a very good quality. Here we have the MIG and TIG process. How you can see, don't have any cracks or porosity. So the visual check, it's okay to proceed the analysis. Now the authors realized a mixture tool analysis. So he takes the sample, have the numbers here, the 2, 3, 4, 5, and 6. So this picture in the edges is to make reference to this sample here. So it's only 3 The precipitated particles are observed in the welded metal up into the heated effect zone. So this figure 6A is this one here. In heat effect zone, large EMP particles are also present. So this one is this one here, is number 3, the number 5. So there's only 4, that's in the middle, in the weld zone, this one here. We have the grains are so different size and have identical orientations, okay? So here we have the friction Chig process. So here we have the sample, and in the edge we have the mixture pictures. Here we have the Chig for zone 2 and 6 is the base material, so we have an elongated grain into the rolling direction. In zone 3-5, the sediment particles can be observed, and the grain has an orientation in the different rolling. So this zone 3-5 is this one here and this one here. In the metal zone, the sediment particle of the different size and the grain has dendritic orientations. So this weld zone here is the number 4 here. So how we compare the Chig and the MIG? We can see that the Chig has a wide heat effect zone because they concentrate the heat. How we compare to this picture here to this one here. Now the results of the microstructure in the frigid steel welding, the grain size in the thermomechanical effect zone decreases towards the negative region. The structure in the negative steel zone is very thinner grain. In the structure, we have some significant number of dark points, how we can see in all this picture here. The mixture of the negative is characterized by a very small excited grains, which is attributed to dynamic hexalization in this picture here, the figure 10F, this one here. So the hexalization, it's the reason why we have like different small grain size. Here we have the hardness comparison. Here is the hardness in the measuring part. In the middle, we can see the decreased hardness because it is the weld zone. In the side, you have the effect zone. So this is the reason why you have increase in the hardness. So we can see the meat and Chig have an increase in the hardness. The same occurs in the root joint. The first one is in the face joint, and the second one is in the root joint. So we have the same decrease in the middle of the weld zone. Here we have results of the friction steel welding. So how you can see, we have the results in 3 different points in the face, middle, and root joint. So here we have the hardness and distance of the weld center. So this is in the middle of the weld zone. Here we have a comparison between the hardness in the MIG, Chig, and friction steel welding process. So how you can see the friction steel welding, we have a high properties than Chig and MIG. Here we have the results of the tensile properties. So how you can see, the friction steel welding has the highest values if you compare in ultimate tensile stress to the Chig and MIG. In the yield stress, we have the height value to compare to Chig and MIG too. And the elongation is height in the friction steel welding and Chig and MIG too. So how you can see, friction steel welding is very next to the base material conditions. So the friction steel welding is 80 stronger than MIG and Chig and is more next to the base metal. So here we have the efficiency of the joint. So the joint efficiency is the ratio of the weld strength to the base material. So is how next to the weld is to the base material. So the friction steel welding is very, very next to the base material, like 97%. And the MIG and Chig is more launch, more. It's not so next to the 100%, so it's in the middle. So it's not so efficient to the friction steel welding. So how you can see in the last one here, the friction welding is very next to the values by the base metal. So this is the reason why we have 90% of the joint efficient. The fracture location in the MIG and Chig is in the soft region, and the fixed welding is in the steel zone. The conclusions by the article is the friction welding is a very superior joint method for these aluminum sheets. The fixed welding is very superior in the stronger, the strength, very superior in joint efficient, very superior in metal hardness. So the reason by the fixed welding superior is because they have a thinner grain because of the verticalization structure. So I think that's thank you for watching my video.